to go ahead and do the answers for these, go over it with you, because sometimes the way these are worded, especially from the books, it can be a little confusing for students as to what exactly are they looking for. Number one, give an interpretation of the following equations in terms of 1 numbers of particles and 2 numbers of moles. The big thing here is just showing that, I think I had them just do moles on this one because I wasn't going to have them jump right into the particle side of things. But if I were to read this, I would say on A, 2 moles of SO2, or you could say sulfur dioxide, added with 1 mole of oxygen gas produces 2 moles of SO3, or you could say sulfur trioxide. So basically 2 moles of SO2 added to 1 mole of O2 produces 2 moles of SO3. That's the answer for A. The answer for B would be 4 moles of phosphorus added to 5 moles of oxygen gas produces 2 moles of P2O5, or you could actually write that out as 2 moles of diphosphorus pentaoxide. So that's all they're wanting. It's just basically for you to write this down like you were reading it. On number 2, they want you to calculate the total mass of the reactants and the products in each of the equations from question 1. Now I just did it once because it's the same on each, which it should be, because you cannot create or destroy matter. So if I'm looking at A right here, you go up here, I've got 2S, and then, let's see here, 2S. I think I put 4 here, but sulfur is, if you look at sulfur, it is 32. So this right here on the answer key, I was trying to do it real quick. This should be a 2. And I think I was doing, I don't know what I was doing with the oxygen. I don't know what I was doing here. But this should be 2 times 32. So that 4 and that 16, ignore. If you look up here, I have 2 sulfurs, and sulfur weighs 32. So I should have a 2 times 32 here. My answer right here is right. That's why I went back and did this to show you guys, and I think I was looking at an oxygen. I'm not for sure what I was doing. So anyways, I think I was looking at the 2O2 right there. But anyways, this should be a 2 times 32, and that is how I got the 64. Now for oxygen, I have 2 O2 right here, so there are 4 oxygens right here. But I have another 2 oxygens right here on the reactant side. So that's 6 altogether. So that's why I have 6 times 16, and that is 96. So altogether, that's 160 grams. Now if I look at the product side, I have 2 sulfurs, which is what I had here, and I have 6 oxygens, which is what I had here. So it should be the exact same. Now on B, phosphorus weighs 31, and there are 4 of them. So I took 31 times 4, and that's how I got 124. Oxygen, there are 10 oxygen, and they each weigh 16, so that's 160. Add that up, and you get 284. Now notice up here on the product side, I've got 4 phosphorus, and I have 10 oxygen, just like on the reactant, so it should be equal. On number 3, they want you to write all the mole-to-mole factors. So if I'm looking at A, I can see that for every 2 moles, right here, I can see that for every 2 moles of SO2, I have 1 mole of O2. So that's why I did this. Now I could flip-flop these. I could have my 1 mole of O2 on top, and I could have my 2 moles of SO2 on bottom. I could also say for every 2 moles of SO2, I have 2 moles of SO3, which is what I've written right here. Once again, I can flip-flop these. And then the last one would be for every 1 mole of O2, I have 2 moles of SO3. Once again, I could put the 2 moles of SO3 on top and the 1 mole of O2 on bottom. B, I'm going to do the same thing. For every 4 moles of phosphorus, I have 5 moles of oxygen. Once again, you can flip-flop those. 4 moles of phosphorus, I have 2 moles of P2O5 right here. I could flip-flop those. And the last one would be 5 moles of oxygen. I can have 2 moles of P2O5. Once again, I could flip-flop them. 4, this is where we are, I think, running into some problems. Some of you have been doing really great, so keep that up. But I am going to be doing all this week. It's basically just a lot of practice with doing these problems. So after section 2, I kind of stop, and hopefully we should be back to school then. So we can make sure we have section 1 and 2 down, that this math is getting under control, and then we'll do section 3 and 4 when you guys get back. Alright, so if I'm looking at A, how many moles of O2 are required to react with 2 moles of hydrogen? Well, I'm starting with this 2 moles of hydrogen. So I was being a little lazy, I didn't write it out, I just put my parentheses outside here. moles of H2, moles of H2 will go on bottom so they can cancel out, and I'm looking for moles of oxygen. So I'm going to put moles of oxygen right there. Anytime it is a mole to mole, you are going to use your equation, and if I look up here it says 2 moles of H2, there's 1 mole of oxygen. So then I'm just going to take 2 divided by 2, and that is 1. Your answer is 1, which makes sense, right? How many moles of oxygen are there when 2 moles of hydrogen? Well, if you have 2 moles of hydrogen, you have 1 oxygen. Now here's the same. If you have 5 moles of oxygen, so basically 1 times 5, I'm going to have to do 2 times 5 to get 10, right? But if you're writing that out, I start with 5 moles of oxygen, which is what I have right here on B. Moles of oxygen are going to go on bottom so I can cancel them out, and I'm looking for moles of hydrogen, right? Use your equation. 1 mole of oxygen, 2 moles of hydrogen. So 5 times 2 is 10. On C, they give me 2.5 moles of O2, so that's what I write down starting with. They want to know how much water. So I'm going to put O2 on bottom, H2O on top. Use your equation. There's 1 oxygen for every 2 H2Os. So 2.5 times 2 is 5. Now these are all one-step problems because we had no masses. There was no grams anywhere in that problem. Now the second we see grams, it's going to turn it immediately into a 2-step problem, possibly a 3. All right, so right now for section 1, it was just that one. All right, if you guys need anything from me, let me know.